Well, I'm excited to introduce you to our guest, Ken Delage. And I should tell you, if you've never been to a Convivium lecture before, it's important for you to understand that you don't have to be bald and bearded to get an invitation to speak at Convivium, but it does help. No, what I want you to know is the challenge I feel that I have in introducing Ken Delage to you is that he has such a diverse resume. Ken was a church planter, the church planting has done now, and it's a church. And so Ken is the senior pastor of Mercy Hill Church in Spotsylvania, Virginia, which is about an hour south of Washington, D.C. And he's been pastoring that church since 2009. He's also a professor at Trinity College of Louisville. And that's part of what brings him here. He came to town to teach his class in person. Ken teaches a class called The Theology and Philosophy of Science. We want our students to be prepared with a biblical understanding of what science is, what it gets done, and what it can't get done, and what the Bible has to say about it. He's going to be talking some more about that tonight. I was excited for Ken to do this class, for him to teach this class, both for Trinity College and tonight at Convivium. I wanted Ken to do this because I knew that as a pastor, I knew that Ken is very thoughtful and thinks deeply about the theology and philosophy of all manner of topics, but especially science, because Ken is not only interested in the philosophy behind science, he's also been a practitioner. He was responsible for a nuclear power plant on a U.S. Navy attack submarine, and so he has actually done science with nuclear reactors, which sounds pretty incredible, and all on a submarine. And so he'll tell you more about that if that's something you'd like to know more about. Ken is adding to his resume. He is also considering starting a K-12 school, a Christian school in partnership with their church. And he's a husband to Tiffany, father to 7 children, including Faith, who's here. Faith is the 4th, so please welcome her and greet her later. Oh, welcome her right now. Yeah. That's great. Sorry, that's great. So I don't want to cut any further into Ken's time, but I trust you know I am very excited about what we'll get to hear tonight, because this is a wonderful orientation to what does the Bible have to say about the topic of science, and how should we as Christians think about this topic of science. We'll have a little bit of time at the end for Q&A. So as we're going along, if anything raises questions for you or piques your interest, you want to ask about that, jot it down, and I'll come back up to do that. So great, Ken.
Great, thank you.
Welcome, Ken. Thank you.
Well, great. Thank you guys for coming out on a January Wednesday night to hear about science. I mean, I don't know who does that. So thank you for doing that. What a delight to get to talk to you about this. So yeah, tonight we're going to talk about science broadly, but more specifically, you might say the laws of nature or the laws of science, and kind of ask the question, what are they? What are these laws of nature? Everybody's heard of the laws of nature or the laws of science. And I want to kind of explore philosophically, theologically, what are these things when we talk about them? All right. So you've got an outline there. I'm going to follow it rather quickly. And so before we get rather closely, so before we get into scientific law, let's just talk about science itself for a second. So what is science? All right. And I've got a definition there for you. Science is the activity of studying the world to discover the processes and order which underlie the phenomena of nature. That's a little bit of a mouthful. But it's a kind of a non-technical definition, and I like it for that reason. You can have a more technical definition. You could use words like hypothesis and peer-reviewed testing and analytical procedures. And you could bring all of these things in, but you don't have to bring all those things in for it to be science. Science works when a 6-year-old boy is holding a frog and is going, how does it jump? What makes it be able to jump? Like, that's a science question, and he's doing science when he does that. Or when somebody's seeking to find just the right combination of colors between a couple different colors on the palette to capture what they're seeing in the sunset. Like, how do these colors blend just right? There's something scientific going on that they're trying to understand about the world around them. If you're going to be, it affects almost every area of your life. You want to be a good cook or carpenter, you got to know how the world works. You got to know something about your craft. You got to know something about science. If you're going to be a shepherd or a shipwright or a farmer or a pharmacist, you talk to any one of them and they study the world, their particular little corner of the world, so that they can understand what's going on behind the scenes, behind the phenomena that we see, what's really going on. And of course, then there's other things that we think of, like maybe a little bit more pure science. Have you heard of the Parker Solar Probe? No? So right now, the human race has sent a little probe closer to the sun than we ever had before. It's there right now. It's orbiting inwardly towards the sun, and every couple weeks it flies through the sun's atmosphere. Through the sun's atmosphere, which, as I understand, is the hottest part of the sun. So, that's a thing. And it comes out not melted every time so far. So we're learning something about how the sun works. This is a scientific endeavor. There's the Large Hadron Particle Accelerator in Europe. It's like a racetrack for atoms. And it's so big, it's underneath 2 countries. Okay? And what they do is they shoot atoms at each other on this racetrack in opposite directions and try to make them hit each other. It's like a bad idea for a regular racetrack. You know what I mean? What'll happen if we run these 2 cars? Actually, that sounds pretty cool. What will happen? That's a good science question. What happens when 2 atoms hit is maybe they break and you learn what's inside. Like inside a nucleus. Ooh, well, that's a science question. And then we've got the best ever telescope right now out in orbit that is looking out into space as far as we've ever seen before, the James Webb telescope. And it's able to perceive things that we've never seen and learn things that we've never known. And that's pure science. And that's exciting to get to see. So science is simply anything from that 6-year-old boy with his frog all the way to this particle accelerator thing in Europe. All of that stuff is science. So 2 quick notes as we get started before we move on to what is scientific law. Just from what I've said already, let me highlight 2 things that are kind of philosophical. And the first is that science is the work of discovery. All right? So that means science is not creative, making something that wasn't there. Science is trying to discover what is there, right? So it's like archaeology. You're familiar with archaeology? Here's what doesn't happen in archaeology. It's the archaeologist tiptoes out. And they take their shoe off and they bury their shoe in the ground. Then they go back and then they come back with a shovel and they're like, behold, a shoe from the 21st century. Archaeology is about discovering what's already in the ground, right? Science is about discovering what's already there. We're trying to understand what makes the world work. Why, when I hold a ball, does it fall? And everybody in here thought, gravity. Somewhere in the back of your head when you heard that, right? Because that's a kind of scientific answer to that. So, but how does gravity work? And why does gravity work? This is getting us into what science is. So this is just from a philosophy perspective. It's an important point that often gets overlooked. When we talk about science, we're doing the work of discovering what's already there, which means we start with an assumption. This is going to sound funny, that something's there. Now, to everybody in the room, that sounds duh. Like that just sounds like common sense, right? Like, of course there's something there. There's a world to study. But I'll tell you what, if you get into philosophy, and particularly non-Christian philosophy, there is no non-Christian philosophy that can prove that the world exists. All right? You can get so into your head about this that you can actually think, I don't know, man, maybe the whole world's just in my head. And I think it's there, but how do I know it's really there? So there is no secular way to get to science if science is the study of what's there. How do we know that there's something there? Because we know in the beginning, God created. And so we can start with there is a creation to study. And that is, while very simple, a rather necessary foundation. And the only worldview that provides the foundation for science is Christianity. It's the only one. The second thing we can point out is that science is the work of discovering the truth about how things work, which means, are you ready? Here's another big concept. Truth exists. The work of science is trying to figure out what it is. Why does the ball drop? Right? Science is trying to figure out the truth about something, which means truth exists. There is no way for a materialistic or naturalistic worldview to account for truth. They can't get there. If you're not familiar with those terms, materialism, naturalism, I'm going to kind of put them in the same bucket. They're very similar. They basically say the only thing that exists is things you can see and touch and taste and smell. You know, if it's physical, it's real. If it's not real. So they would, for example, then say we don't have a soul. We're just human, physical, right? So if you're in a materialistic world, well, what is truth? Can you knock on truth somewhere? Is it in a box in the corner? Did we break the breaker and now truth is turned off? Like, what is truth? Well, the Christian worldview has no problem with it. Truth is right at home because there is one who said, I am the way and the truth and the life. And so we would say not only is truth real, but we know who he is, and his name is Jesus. And so there's no problem from a Christian worldview getting to some pretty basic assumptions that science needs. You know, there's scientists that spend their whole career, their whole life pursuing truth who don't believe in truth. I mean, that is no trouble. Should I pause for you? So, okay. All right. So to me, it's a really sad existence that people spend their whole life pursuing truth. And while they're at work, they know they're trying to figure out, why does the ball drop? You know? But then if you were to ask them, tell me about truth, they can't articulate that it's real. They don't really think it's real. Praise God, we've got a strong foundation from which to do science, that there is a world and that we can know it and that there's truth to actually go figure out. Okay, so that's science. What is scientific law? You following me? We're on the second big question. What is scientific law? Okay, so our world acts in... Faithy, could you turn that off? Or I'm just going to cook. Thank you. Yeah, I'm getting a suntan. Burn my head. What is a scientific law? Our world acts in predictable ways. All right, these are the way things always work. The ball always falls to the ground when you drop it. Flowers grow in the sunshine, but not in caves. Fish, when they have little babies, are fish, not cows. Ever, never ever has a fish had a cow, right? Planets orbit in such precise, predictable, regular ways that scientists can tell you where Jupiter is going to be in 10,000 years to the precise location. It's predictable. The world is predictable. Scientific laws describe why things are predictable. So I'm going to give you the definition that's written there on your page. Scientific laws are our description of the regularities of our universe, the underlying order behind the phenomena that we see. So examples of scientific law. You've got the laws of thermodynamics. And so here's the laws of thermodynamics. First, they discovered a law of thermodynamics, and they called it creatively the first law of thermodynamics. And then they discovered another one, and also creatively, they called it the second law of thermodynamics. And then they discovered a third law of thermodynamics. And they went, oh no, this one's more important than the first two. What do we do? And so nerds that they are, they called it the zeroth law of thermodynamics. All right? So you have the zeroth law and the first law and the second law of thermodynamics. Those are laws that describe heat transfer and these kinds of things in the universe. Okay? You've got Newton's laws, right? Which if you've taken any middle school science and up, you've heard about Isaac Newton and his laws of motion, right? So those are laws of the universe. The ideal gas law is a law that describes how temperature and pressure and volume work in a gas. And then you've got Einstein's mass energy equivalence. What's that one? Oh, I heard it. What is it? E equals mc squared. Do you know what this means? This is a marvelous law. Can I tell you about this law for a second? Okay. All right. So I served on a submarine. E equals mc squared is why submarines move around in water. Like nuclear reactors work on this principle. So here's what an equation means in math. When you say E equals mc squared, you're saying equals means same as. We're going to say this is the same as this. Now, what's amazing about that is you put things that are different on either side, but you say that they're the same because they are functioning the same. Okay, so let me see if I can get you through this without any visual aids. Okay, on the one side we have, here's our mc squared side. Go mc squared. Okay, you guys are the mc squared side. All right. So what is mc squared? Well, first we'll start with the hard one, which is c squared. All right. C squared is just c times c. What is c? It's the speed of light. Okay? So the speed of light is fast. Light is fast. What if you multiplied that fast by that fast again? Okay, you end up with a big number. I think it's like 90,000 trillion meters per second. Okay? Big number. That's bigger than our national debt by a couple trillion. Okay? It's a big number. All right, so you've got this big number. Just forget about c squared. It's just a big number. And next to it, you have m. M means mass. So it means stuff. So think of like a bean. Okay? We have a bean. It's a small bit of mass. It's a couple grams. Very small thing. But we're multiplying it by 90,000 trillion. Okay? So you take this little thing and you multiply it by 90,000 trillion. And that equals you guys. Team E. Okay. Oh, yeah, they're better. I'm sorry. You know why they're so loud? Because they're energy. Go energy. Their energy is very energetic. Mass is just like we're mass. All right. So energy's like cheering. So here's the crazy thing. Energy equals mass. Stuff is energy. What? Like this is so, it's kind of mind-blowing, but if you could take stuff and like make it go away from the universe. I'm not talking burn it and it goes up in the air like a fire. That just changes one state to another. I mean, make it disappear from the universe. It would turn into unfathomable amounts of energy because this little bean of stuff got multiplied by c squared. Right? Which is why you can load a submarine with a little core of uranium and it will drive around the world for 30 years without refueling. For 30 years. Or God loads helium atoms into the sun, and that sun could, if the Lord desired, burn for the next 10 billion years. Something like that. I mean, a long time. And the sun puts out kind of a lot of energy every second. Right? Like, it's warm. It's warm all the time. Lights up our whole solar system. Or if you take a bit of uranium, which would be too heavy for me to hold, but I could hold, and you put it together in the right configuration, you take out all of Louisville in a moment. That's the power of this equation that we're talking about. This is a law of nature that you can convert a very small amount of mass into an unfathomable amount of energy. Okay, so there you go. E equals mc squared. Maybe you understand that law, which is awesome if you do. But it's an example of a scientific law. Now, let me talk more about scientific laws, because there's two ways people talk about it. One is, we might say that the law is our best attempt at saying what's true about the universe. So, in other words, when we do that, we can be wrong. Humans can be wrong, and we have been wrong in the past. Science is a kind of iterative process that over the years, hopefully, we're refining our hypotheses. And we're like, ooh, we didn't say that quite right. Actually, E equals mc cubed or whatever, right? Like, actually, there's a little tweak we need to make in that, and we need to get our articulation closer to what's true. Does that make sense? So that's a way people talk about scientific laws. But there's another way, which is to say the law is just what is. And that's what we're trying to understand. And I want to spend the rest of our time talking about that thing, that law that is. It may be E equals mc squared. I think we probably have that right. You got to be careful about these things. Like the different laws, the last 200 years, they've changed dramatically. So like we're still learning as we go. But all of these are an attempt to get towards truth, which is the real scientific law that really is there. That's what I want to talk about tonight. What is it that's really there? When we say it and there, what do we mean and what are we talking about? So I changed your definition at the bottom, and I one-lined the words "our description of." I made them really tiny, and I one-lined it. So now scientific laws are what governs our universe. They're the underlying order behind the phenomena we see. And they govern the universe. So for the remainder of the lecture, we're going to be, what is a scientific law? So when we say E equals mc squared, if that's really true, why? Why is that true? Why does that hold? Why does that bind all of nature to that truth, and nature can't disobey? It has to do it that way every time. Why is it that? Okay. So to answer that, I want to go through attributes of scientific law. And there's several attributes that are written in there on your page. And we're going to kind of go through them one at a time. So I'll introduce each one with a kind of explanation. Okay, so the first thing we'll say, scientific law. And by the way, as I say these things, I don't know of anything I'm about to say that would be refuted by a secular scientist. I think every secular scientist would also agree with these definitions, as I say. They might use slightly different words or something, but we're going to agree on these definitions, okay? So first thing about a scientific law is that they are true everywhere in the universe, all right? So if there's a place in the universe the law doesn't apply, then it's not a law, okay? That's how that works. So if you measure the speed of light on Jupiter, you should get the same answer that you get on Earth. And we would also say that if using the James Webb telescope and you peer out as far as you can to the most distant galaxy, and then you know that beyond that are galaxies we cannot even see. And we would say for a galaxy we will never go to, and a galaxy we can never see, if we were to go and see, the speed of light would be the same there as it is on Earth. That is a profoundly big thing to say about the universe. And that's what we're saying about scientific law. It is true absolutely everywhere. So a word we can use for that is omnipresent. Scientific law is present in all places. All right, the next one, scientific law is true all the time. There's no time when the law takes a break, okay? It's always true. So if you go back to ancient Egypt and stand on the top of that brand new pyramid, you know, when the pyramids were new, and they're looking all shiny or however they look. You're standing on the top of the pyramid, and you're balancing on the top of the pyramid, and you're measuring the speed of light coming down to the pyramid from the sun and bouncing off. That measurement would be the same as if you measured it today. And no matter how far back in history you went, nor how far into the future, so long as there is time, however far into time you went, you would measure the speed of light and it would be the same. The laws do not change over time. And so the second one is eternal. Scientific law is present at all times. Okay, very closely related to that concept that it's true across time is that it doesn't change. And that's what we kind of gave the definition of scientific law, is it describes the regularities of the universe, you know? So imagine that I hold out a ball, right? And I remove my hand and the ball stays there, and you're like, oh, gravity. You know, it's just doing that thing again. You know, every once in a while, woo! That's right. It's gravity's day off. I forgot. You know, like that's not how it works, right? Like the law is always true. It doesn't change. Like, oh, there goes the moon. Oh, can we get that back? I don't know. It's just not orbiting the Earth anymore, right? Like that's not how law works. It is the same. It doesn't change. It doesn't take a day off. And so a word we can use for that, so these are theological words, is immutable. Scientific law does not change over time. All right, the next one, scientific law is real. Okay, so when I say real, I mean it is as real as ice cream. But you can't taste it. It's as real as thunder, but you can't hear it. It's as real as the wind, but you can't feel it. Its influence is so obvious that for 3,000 years, humans have been in the pursuit of trying to understand it. Like, it's obviously there. But where? It can't be tasted. It can't be touched. It can't be heard. It takes up no space. Like, as though I could put scientific law in a shoebox. Like, it doesn't take up space. It has no volume. It has no mass. It doesn't weigh anything. There's nothing material about it. And so that one is immaterial. Scientific law has no mass. And by the way, let me just, real quick. Scientific law is immaterial. That is very problematic if you are a materialist. And all you believe is things that are real, as if you can see them, if they are in fact material. You cannot be an honest, materialistic scientist. Because you're seeking that which is immaterial while claiming there's nothing immaterial. But they do it all the time. This is the inconsistency required in the secular mindset. It is required in order to do science. You have to be inconsistent if you're a secularist. Okay, closely related to immaterial, we know that scientific law is present. It's in the room right now. It's here. It's with us. It's as real as the sun, real as these lights, but you can't see it. You can never see it. You cannot see it directly. You can see that it's there by its influence, by what it does. When I drop the ball and it falls, you know that gravity is here. But you can't see gravity. It is invisible. Scientific law cannot be seen. All right, the next one is that scientific laws govern. They have power, my friend. Just pretend for a day that gravity doesn't have power. It is not going to go well for you. I promise. Like, I'll take you up on the roof. And we can pretend, if you want, that gravity doesn't work. But gravity doesn't pretend. It's just in charge. Now, you might have an airplane that can use some other laws to disregard, apparently, gravity. But there is no just disregarding gravity. Gravity always rules, and it has actual power. In fact, it has so much power that never has a planet disobeyed. Right now, planets are governed inexorably. They cannot but do what gravity says. They have no choice. And same with you. That's why you're still in your chairs instead of floating on it right now. Except for these guys. So scientific laws, it's not a theory. It's not something we come up with. It actually does rule nature. Okay. And nature is absolutely powerless to resist. Nature is in the hands of and under the sway of scientific law. Never in history has nature rebelled and done other than what scientific law said to do. So it is omnipotent over nature, all powerful. Okay, couple others. We got 4 left. Scientific law is over all of nature. We just said that, but it is not really of nature. In other words, like this is my key to my hotel room. It's not like this. This is a part of nature, right? Like this is just, but it has to obey gravity. Gravity's not it. Gravity's not a part of nature like you could find it, in that corner behind the plant. There's the gravity thing over there, right? Like gravity is over and not a part of nature. It's bigger than nature and ruling over nature. It's distinct from creation. So the theological word we use for that is transcendent. It is not of nature. But at the same time, it touches everything, touches every corner of the universe. So from one end of the universe to the other, there is scientific law. Now that makes it feel far away, but let's bring it in and say, if I had somebody have a pencil or a pen, look at the end of your pencil or your pen and how sharp it is. Imagine you could zoom in and zoom in and zoom in and zoom in to the atom on the end of the pen. And then you could zoom in inside of that atom. And I don't care how deep you go and how close you look, scientific law is still there. It's right there. And right now, in you, it is governing the air that you breathe and the way that your lungs are able to pull that air in. It is governing the chemistry in your brain. It's governing the heat transfer in your body. It's governing the material properties of the bones within you. It is literally within you right now. Scientific law. It could not be any closer. There's no way to get closer. It is as close as is possible. And the theological word for that is imminent. Scientific law is very near to creation, woven in and around all of it and through all of it. Okay, last 2. Scientific law. I tell you, I haven't done a lot of pure science. I've done a lot of applied science where you're like applying what other people have learned, right? Pure science is exciting when you discover something for the first time in the history of the human race. That's pretty cool. Yeah. To be like, whoa, check that! This is why it works. Like everybody wants to do that if they're a scientist. It's really exciting. It brings you this sense of awe and wonder. But here's how it is: when you answer a question from science and you actually get to the answer, you know what that does? It creates 3 more questions. And okay, well then you get to one of those. You know what that does? 3 more questions every time. There is no bottom to the pool. You can swim down and down and down and down and down. We can't get to the bottom. It is incomprehensible. Scientific law is beyond our ability to fully comprehend. We can't plumb the full depths of the universe and the laws of nature. Okay, and yet we can know true things. We know E equals mc squared. We don't know all the why. We don't know a lot about the c in E equals mc squared, or the E, or the m for that matter. We got a lot of questions about the whole thing, but we can say that E equals mc squared. So we are able to say true things about the universe, state true facts about it, know things truly. And so this is called being knowable. Scientific law can be truly known, if only in part. All right, I'm going to summarize the attributes for you that we just went over. Omnipresent, eternal, immutable, immaterial, invisible, omnipotent, transcendent, immanent, incomprehensible, but knowable. Does this remind you of anyone? These are a list of things that theologians for 1,000, 2,000, 3,000 years have ascribed unto God and to God alone. These are divine attributes. Everything we've said, these are divine attributes. Okay, so then, all right, those are divine attributes. So what are scientific laws? Like, what are we saying? Are we saying that scientific laws are divine in the sense like maybe there's a fourth person of the Trinity? Father, Son, Spirit, and law. No, that is heresy. We are not saying that. We're certainly not saying that. Okay, there's God, but maybe then God like gives like to scientific law his power. And it's sort of like rules in his place. Like it's his steward over the earth. Many people have thought such a thing. That's called deism. And the idea is that God created the universe, wound it up like a clock, and then lets it run according to the laws of nature. So maybe the spring inside the clock are the laws of nature by which nature runs, but apart from God. That is deism. That is not Christianity. And that is not Scripture. So that's not right either. So I'm going to try to explain what scientific laws are, but I'm going to have to blow your mind first, because I'm doing this whole talk on scientific laws, and now I'm about to say that they do not exist. Not in the sense that perhaps you thought of them when you came in. I'll be honest, not in the sense that I thought about them before I started teaching the class at Trinity. They don't exist if what we mean is that they exist in some independent way. Here's scientific law over here, and here's God over here, and scientific law governs the world. No, they don't exist like that. That's not true. That's just not a thing. When we speak of scientific law, we are not speaking of something distinct from God. What we're speaking of is God's right now power holding up the universe. His right now, always, never changing power at work, making the universe do what he wants it to do, moment by moment by moment by moment. That's what scientific law is. Hebrews 1:3. This is speaking of Jesus, and it says, and he upholds the universe by the word of his power. Now, you might have read that before. I don't know if you thought about that scientifically before. He, the risen Christ, upholds the universe by the word of his power. That is right now. Right now, if Christ stops speaking, everything stops existing. E does not equal mc squared unless he keeps speaking it and speaking it and speaking it and speaking it. When we speak of scientific law as Christians, what we are really referring to is the powerful word of Christ by which he governs the universe. To me, this is the most astounding and beautiful truth in science, that when I study science, I'm learning something about Christ and the way that he governs things. And so, written down for you, scientific law is nothing other than the word of his power. Scientific law is the word of Christ sustaining his universe moment by moment. And because it's Christ who's speaking, because it's God who's speaking, well, his word is in fact omnipotent and eternal and immutable and immaterial and invisible and omnipotent and transcendent and all of these things that we've been talking about. All of these divine attributes of God are true about the word of Christ as he speaks it. And so they're true about our universe. Got a couple quotes in there. Both quotes are from Redeeming Science. And by the way, most of this lecture comes from chapter 1 or 2 of that book, so you can enjoy that. It suffices to observe, Poitras says, that in reality, what people call scientific law is divine. We are speaking of God himself and his revelation of himself through his governance of the world. Okay. So what would you think if I took this chair here in front of me and I said, that chair is omnipotent. And it's all powerful, it's eternal, it's immutable. And I ascribed unto it all these qualities of God, and I stood in awe of this chair. What would you call that chair? To me, an idol, right? That would be an idol. If you ascribe qualities that are God's to something that is not God, you have created an idol. And what modern scientists do is they come up with this idea, scientific law, and they ascribe to it all the qualities of God. But they ignore the God who is the lawgiver. But they ascribe it all to what they have set up for themselves as a modern day idol. Might not be covered in gold, but it is an idolatrous idea. And it's one of the ways that we as human beings try to weasel our way away from God and deny that he exists. And so you'll encounter it over and over. People that speak of scientific law with all the divine properties, but have no knowledge of God himself. And Poitras again says, modern people may no longer make idols in the form of physical images, but their idea of scientific law is an idolatrous twisting of their knowledge of God. Okay, so almost done. Why study science? Gosh. What gets me excited about E equals MC squared? Well, it does run the coolest ships ever. I'm just being honest. Okay, I mean, like that is a thing. There is something delightful about studying science that's fun and exciting and all of those things. But when we think about like, oh, we got to E equals MC squared, this is a description of the word of Christ. Now, I'm a Bible man. Much of what I got tonight was from the Bible, but there's something we learn of God through the world because he speaks it. And we learn something of the mind of Christ. And when we see this phenomenal thing, what runs the sun? 3 letters with an equal sign between them. That's elegant. That's wise. That's amazing. How could he have thought of that? We're learning something of the mind of God when we study these things. It's these little equations. These are the sheet music that Christ sings into creation. So science is not just the pursuit of like, let's learn this principle and then stand in awe of creation. No, it's like, let's learn this principle that we could understand the mind of our Creator and stand in awe of our Creator who could do all of this by the word of his power. You might be familiar with Psalm 19, 1 and 2. I'll close with this. The heavens declare not the glory of the heavens. They declare the glory of God. The sky above proclaims his handiwork. Day to day pours out speech, and night to night reveals knowledge. So this is why scientific laws are God's scepter. Boom. He governs the world in this way by the word of his power. There we go. Thanks for listening.